This is a P1 energy video. Ultimately, we're looking at reducing unwanted energy transfers. But before we get onto that, I'd like to go through a definition of conduction and convection to help us understand the next part of the topic. So, conduction occurs in solids. It's when energy is transferred to the thermal store of the object by heating. As the particles are heated, they vibrate and the energy is shared across the kinetic energy stores of the particles. That sounds quite involved. Let's have a look at the picture. So, we have an object here and we are heating it. We can see the energy is being transferred to the thermal store of the object by heating. And what we can see is that these particles here that have gained that energy are vibrating more. Okay, so as the particles are heated, they vibrate more and the energy is shared across the kinetic energy stores of the particles. The particles are vibrating on the spot, therefore they have more kinetic energy. And another thing that's really useful to point out at this point is that the particles are the same size depending on whether they have energy, more energy here than they do here, less energy. But because they're vibrating on the spot, they're taking up slightly more space and we get that expansion of the object. Okay, so we can't say that particles expand, that would be incorrect, but we can say that the object expands slightly as the particles vibrate more when they've got more energy, taking up more space. So conduction in solids, and it's about energy being transferred to the thermal store of the object, okay, and the particles are gaining that kinetic energy store when they're heated because they're vibrating more. And then we move on to convection. Convection occurs in liquids and gases. It's about energy being transferred to the thermal store of the liquid or gas particles by heating. We said that previously, but we were talking about solids. Again, just like the last example, energy is shared across the kinetic energy stores of the particles. Liquids and gas particles can move. That's how they're different from the solid particles. That means that convection currents can be formed. And there's an example here. You need to know about how radiators work in heating up the whole room. And there's an example here to explain it. So we can see here at point 1, we've got the hot radiator. And that is causing the particles in this area to gain energy. Because the particles have gained energy, they move faster and they spread out. Just how we saw that spreading out in the conduction picture, they spread out. Now, the particles do not change. They've got more energy, but they are the same particles. What happens is that body of air, because the particles have spread out, the body of air becomes less dense, which causes it to rise. Okay, so it's the body of air that becomes less dense. Now, this moves across the room, and at point 2 here, we can see that the particles have lost quite a lot of energy because they're not being heated anymore. They move more slowly, and they get closer together. So rather than spreading out in the warmer region of the room, they get closer together. So the body of air becomes more dense and sinks. And this movement in this cycle is called a convection current. Okay. Now that was my introduction, which leads us on to talking about reducing unwanted energy transfers. And we're looking, first of all, how we can reduce frictional forces, and then we're looking at unwanted energy transfers in the home. So for frictional forces, most of us have ridden a bike and know that the chain has lubricant on it, okay, in the form of oil. That reduces the frictional forces, okay, makes it more efficient a bike to use. Okay, car engines require the same oil, okay, to lubricate the parts of the engine that rub together to reduce those frictional forces, and this reduces how much energy is dissipated. Okay, a lot of that energy will be released as heat energy. Okay, so if we can reduce the friction, we can reduce the amount of energy lost as heat. It makes it more efficient. Let's look at the second example. Air resistance on a falling object can transfer energy from the kinetic energy store to the thermal energy store. So that's friction of the object with the air. To reduce this, streamlining. Okay, so we can reduce that by streamlining our object. And then we go on to talk about insulation in the home. Okay, and things we can do in the home. Loft insulation prevents convection currents in the loft. So you can see where I've just talked about convection. Double glazed windows prevents energy transfer by conduction because the double layer of the window has it's basically a vacuum between the two layers, so it has all the gas removed, so therefore you haven't got the particles to transfer the energy. The loft insulation is just trapping lots and lots of gas. Draft excluders reduce energy transfer again by convection. You have them around the edges of the doors. You might have something at the bottom of the door. And cavity wall insulation. So the building has the outer skin of wall and the inner skin of wall, and there's a gap in between. So it's kind of like double glazing. And we can fill that with cavity wall insulation, which is kind of like expandable foam. Lots and lots of gas bubbles trapped in there to reduce energy transfer by convection. We can also think about the materials that we choose. When we're building a building, we can choose materials with low thermal conductivity, so they don't conduct the heat away, and that will reduce the energy transfer by conduction. Okay, so lots of different ideas there for how we can reduce energy transfers in the home. Hope you found that useful. Thank you. One last thing to add to this is we can include payback in here. So the payback of loft insulation. Loft insulation is really quite cheap. Okay, let's say we spend £20 on our loft insulation, and each year it saves us £40 on our energy bills. That means that after the first £20 saving, we've paid off the loft insulation, and that would take 6 months to do. Okay, so if it's £40 saving in a year, the loft insulation costs £20, then after 6 months we are then saving money. So we say it's got a payback time of 6 months. Okay, things like the double glazing, that's going to have the longest payback time. It's expensive to fit, and it doesn't actually save us that much energy each year, so it has a long payback time. You've really got to think, I'm going to live in this house for a long time to invest in double glazed windows and then get some payback from it. Hope you found that useful. Thank you.